we're going to use the limit as theta goes to 0 of sine theta over theta equals 1 to derive another important limit, namely that the limit as theta goes to 0 of cosine theta minus 1 over theta is 0. So let's look at this limit. The limit as theta goes to 0 of cosine theta minus 1 over theta, and we're going to try to multiply by cosine theta plus 1, and of course then we must divide by cosine theta plus 1 to keep our fraction the same. So now we have a minus b times a plus b, which is a squared minus b squared in the numerator, and we're looking at the limit as theta goes to 0 of cosine squared theta minus 1, that's a squared minus b squared, over theta times cosine theta plus 1. And recall that sine squared plus cosine squared is 1, so this is the limit as theta goes to 0 of cosine squared theta minus sine squared theta plus cosine squared theta. And now we get a little cancellation in the numerator, and this is the limit as theta goes to 0, and I can take one of those sine thetas from the theta squared, divide it by theta, and then it's the limit of that times the limit of minus sine theta over cosine theta plus 1. And of course, this is the product of the limits. So it's the limit as theta goes to 0 of sine theta over theta times the limit as theta goes to 0 of minus sine theta over cosine theta plus 1. And this, of course, is a continuous function because as theta goes to 0, cosine of 0 plus 1 is just 2. So I can just plug in the value of theta here, and I get that this limit is equal to 0. And of course, this limit we've just shown is equal to 1. So the entire limit is 0, and we're done.